start talking about polynomials. Okay. With polynomials, we're going to define those today, and we're just going to do a little bit of everything with them. Okay. Today is a little bit more of defining a polynomial and learning a little bit about them. We'll add and subtract and multiply them and divide them and all sorts of other fun stuff eventually. So, definition. A polynomial is the sum or difference of one or more terms, which are then called monomials. Okay, so as you look down, I don't have them on the screen, but examples A, B, and C. Those are all examples of polynomials. They're terms just added and subtracted. Now, specifically, a monomial, which is just a single piece of that, is a real number, a variable, or a product of real numbers and variables with whole number exponents. So in other words, a monomial could be a number, such as 13, could be a variable, such as m, or it could be a product of real numbers and variables, such as 12xy. Okay, all of those things are monomials. Put them together, add and subtract them, they become a polynomial. Okay. We're going to talk about standard form. You guys are already familiar with standard form. Standard form of a polynomial, arrange the terms by degree in descending numerical order. So when we talk about the degree being the power, and we're going from highest power to lowest power is our standard form. We're going to practice that a little bit down here on A, B, and C. We're going to talk about the degree. And the degree of a polynomial is the greatest degree or power among its monomial terms. So basically, the highest exponent, your highest power, that's the degree of the problem. And then leading coefficient. That refers to the non-zero factor that is multiplied by the greatest power of x. Basically, find your highest power. That term tells you the degree. The leading coefficient is the coefficient in front of it, the number in front of it. And we'll go over that here in a moment. So there's a chart here, and this chart is not a chart I make you memorize. It's a chart that you just need to be familiar with and understand. It will be provided. But we can name things in a couple of different ways. One, we can name them based on their degree. If the highest power you see is a power of 0, then that polynomial can be called a constant. If the highest degree, so the highest exponent is 1, linear. If the highest exponent is 2, quadratic, right? We just did a whole chapter about quadratics. Highest power of 2. Highest power of 3 is cubic, 4 is quartic, and 5 is quintic. So names you can use when talking about degrees. We're also going to talk about the number of terms. And when we talk about the number of terms, if there's just one term, that's a monomial. Mono standing for 1. 2 terms, so 2 terms added or subtracted together, is a binomial. Is it a bicycle? 2, binomial. That means 3 terms is a trinomial, as in tricycle, right? And then past 3, we don't have a specific name. So you notice for 4, it just says polynomial with 4 terms. We get generic there. 5 is going to be polynomial with 5 terms. Polynomial with 6 terms. We don't have anything specific here. Okay, so those are some charts you can reference. Okay, let's look at our first section here, classifying polynomials. We're going to start off by writing each polynomial in standard form, and then we're going to answer 3 questions: the leading coefficient, the degree, and the number of terms. So let's look at A, and let's start off by looking at standard form. Thoughts on standard form here? What do you think, Ian?
2x squared minus 4x plus 9.
I agree. You guys agree with him? He said 2x squared minus 4x plus 9. Because what's that doing? It's going from highest power to lowest power. So x to the second, x to the first, and then no x would be x to the 0. So there is your standard form. Okay, we're going to use that now. And we're going to talk about the lead coefficient We're going to talk about the degree. And we're going to talk about the number of terms. Okay? So there's the other three pieces. Before we talk lead coefficient, let's talk about the degree. I'm going to go out of order, sorry. Degree. You look up above, the degree is the greatest degree power among its terms. What's my degree here?
2.
2. The highest power is a 2. Specifically this 2, yes? Okay. Now, in my notes, I just have 2 written down. However, there is a name associated with it. A degree of 2 is quadratic. I'll be honest, I don't remember what Savas wants or what they use. So be familiar with both, right? It's a degree of 2. The word is quadratic. And that is because of that 2 right there. That's the reason it's a degree of 2. What's the leading coefficient? 2 because it's a number out front, yes? So it's also 2. Sorry, bad example here, isn't it? The leading coefficient is 2 because of 2, the number multiplied in front of the x squared term is a 2. The degree is 2 because the power x to the second is a 2. Not to be confusing there. And number of terms. How many terms are there? How many? 3. 2x squared minus 4x plus 9. So there are 3 terms. And again, I just have 3 written in my notes, but what would be the word to describe 3 terms? Trinomial. And I definitely use that vocabulary at times as well, so good to know. Okay, are we good there? Okay, let's keep moving. B. I want to start off again by talking about standard form. Thoughts on standard form? Other than I think one misspeak in there, I think so. Okay, starting with the highest power of 5, right? Negative 3x to the 5th. Notice it's a minus, keeping the sign with it, minus 5x to the 3rd. Plus 2x plus 6. I think there's a misspeak in there, but not that it was bad, just, okay. Okay, we good with that? I always say go for standard form first, that way you have all your pieces in order. And now talk about leading coefficient, degree, and number of terms. Okay, what's my degree here? 5. The highest power is 5. So we have a degree of 5. Okay. If we're going to give a name to that, a degree of 5 is what? Quintic. What's my leading coefficient? Yeah. Leading coefficient is negative 3 because find the degree of 5 and it's the number out front, yes? And number of terms. How many terms are there? 4. So no fancy name here. It's just a Polynomial with 4 terms. Nothing crazy going on, right? You with me? Okay. And C. One more go at standard form. Hello. I will send her your way. I don't know. Okay. Bye. That's for you and I. Okay. Standard form.
I like to select the.
Do we combine?
Do we combine? What do you mean, do we combine?
There's like,
Solve for
Yeah.
puzzles.
Well, here's the key. When we start asking which term goes first, you get into a little bit of a quandary, yes? Which term goes first?
Cube.
It's a cubed, but do I put 2x to the third first or 4x to the third first?
I'd say 4.
You combine the two. Okay? Like terms, folks. Like terms. We are going to combine for like terms here. So 2x to the third plus 4x to the third is going to be 6x to the third. And minus 2x squared. Because we have another set of like terms, yes? Okay? So yeah, when you start having that weird question to yourself of, I don't know which goes first. How do I know? Does 2x to the third or 4x to the third go first? Stop and say, wait a minute, I can put those together. Okay, so we're going to use that standard form to answer the rest of our questions of leading coefficient, the degree, and the number of terms. So what do you got for me? It's a degree of 3. My highest power is 3. A degree of 3, if you want a word for it, is a cubic. If the degree is 3, what's the leading coefficient? 6 is the number in front of that term. And number of terms. How many terms are there? We're down to 2, aren't we? Go for in standard form. Once we've got them all put together, we have 2 terms, or in other words, this is a binomial. Okay? Okay. That's stuff you've seen before in varying levels. That's Algebra 1 stuff. You've seen it before, not brand new, but know your vocabulary there, know what we're doing. Okay, at the bottom of the page, before we go to the examples on the back, there is a chart here. And this chart talks about end behavior. So end behavior is what your graph is doing at the ends. So at the very, very left end and at the very, very right end. What is your graph doing way out there? Okay, that's what end behavior talks about. Now, end behavior very much is dependent on the degree of the polynomial and the sign of its leading coefficient. Okay? Let me relate this to what you know. Y equals x squared. What do you know about y equals x squared? What's your graph do? It's a parabola, and the ends go up and up, yes? So I'm going out of order because I'm trying to go off of what you guys know. I'm looking at the second example here. This is an example of y equals x squared. Now, it's y equals x squared, however, it's any even degree, which means it's y equals x to the 4th, y equals x to the 6th, y equals x to the 8th, y equals x to the 10th. Anytime it's an even degree and a positive coefficient, so positive x squared, your ends both of them are going to go up and up. This book talks in terms of infinities. So we'll talk about that it's going up to positive infinity. But I had a previous book that instead of using the infinities, they used just the basic words up and down. And so I think they're helpful to realize that if it's an even, both pieces are going the same. And if it's positive x squared, they're both going to go up. Now, what changes if I say y equals negative x squared? My parabola that was up is going down. Now, that's an example. Okay, so now I'm over here at the fourth example, right? That's an example of, again, any even degree, but this time a negative lead coefficient. So negative x squared, negative x to the fourth, negative x to the sixth, negative x to the eighth. All of those, in the end, are going to go, and you can use the words if you want, down and down. Anytime it's an even power with a negative coefficient. Okay? Those are the two that are easy for you guys to pair up. Okay, so I'm trying to grow off of what you already know. I have confidence you guys know x squared and negative x squared. Okay? Now, odd. The example I use for odd, I don't know if you are quite as... I like to use y equals x cubed. Although I'm learning not everyone really knows y equals x cubed. Okay? Y equals x cubed is this curvy thing that it starts low and it kind of curves over and then goes up. Notice, y equals x cubed is an odd power, and this is a positive coefficient. Notice, where does it begin? It begins low or down here, and it ends up. We're not talking about what the middle of the graph does. Who knows how these pieces connect? I'm just talking about the ends, what happens on either end. Now, my morning class wanted to relate it to a line. Could we think of it as a line with a positive slope? You could. If you wanted to think y equals positive mx plus b. That's what it is, because positive mx plus b, what's a line with a positive slope? It starts low and ends high, right? It's climbing. It's an increasing line. So this is when your power is odd and you have a positive lead coefficient. Now, just like a negative flips a parabola upside down, what's it going to do with an odd? It's still going to flip it upside down. So over here to our other one, my example here is going to be negative x cubed. And with negative x cubed, the idea is it starts high and ends low. Or if I want to use my words again, it starts up and it ends down. Again, odd powers. It's up and down or down and up. If it's negative, it's going to start up and end down. I forgot to put words over here, didn't I? This first one would have been starting down, ending up. I don't know if those words help or not, but I think it makes it a little bit more obvious. And on this other one we just did, could you think of it as a line with a negative slope? You could, because a line with a negative slope does what? Yeah, it goes the opposite way. It's moving down as it moves to the right. Okay, you've got this chart, yes? Work to understand it, be familiar with it. Evens, they're either going to be both up or both down, depending on positive or negative. Odds, you're going to have one of each. Either up and down or down and up, again, depending on signs. Now, let's go see what kind of questions this chart can help us answer. Okay, so flip to the back side. And the back side, they don't give us a pretty graph. They give us equations. Okay. And they ask us to use the leading coefficient and the degree of the polynomial to determine the end behavior. Okay, so what's this graph doing as it goes off to the left and off to the right? Now, we're going to throw infinities in as we read the questions and answer the questions, but I'll explain as we go here. So, on A, f of x equals 2x to the 6th minus 5x to the 5th plus 6x to the 4th minus x to the 3rd plus 4x squared minus x plus 1. Okay, big long equation. You know what? Majority of that equation doesn't matter. We're being asked to use the leading coefficient and degree. What is the degree of this problem? 6? You guys with her? The degree is 6. What do we know about the number 6? It is even. So far, so good. I know that this has an even degree. What else do I know?
It's not negative. Number.
Okay, the number connected to it, or in other words, what I'm going to call the leading coefficient, is 2, and that is a positive 2. Yes? So our leading coefficient here is positive. I don't have a real great place to write all of this, but that's what you have to acknowledge. My power, my degree is even. My leading coefficient is positive. Now, I personally can do this without looking at the chart. I'm also the teacher. Okay, even. Even? That's an interesting alarm on someone's phone. Okay.
No.
Someone's going to have to turn that off, guys. Or maybe it's going to go off on its own. Okay. Even. What do we know about even, folks? Think y equals x squared. It's either up and up or down and down. Now, what about this one? It's a positive and even. So that means my end pieces are going to go up and up. Now, whether you write the symbols, whether you write the words, whether you just keep it in your brain. Notice that's off to the side. That's not my answer, is it? I said we're going to use infinities. Okay, so look at the first question. As x approaches negative infinity. So which way are we talking if x is approaching negative infinity? Negative infinity in terms of x's is to the left. So this is saying as my graph moves to the left, okay, as x approaches negative infinity, as my graph moves to the left, what is the end behavior? Well, on the left side, what is my graph doing? It's going up. What is up? In terms of y, well, is it positive or negative infinity in terms of y? It's positive infinity. So as x approaches negative infinity on the left side of the graph, y is going to approach positive infinity. In other words, which way is my graph going? Up. So when you say y approaches positive infinity, that you're answering that your end behavior is going up. If we had needed to say down, we would say y approaches negative infinity. Am I making some sense? A little bit. Okay, give me it's gonna be repetitive. You'll give it a chance here then. As long as I haven't totally left you in the dust, we're all good. Now, what's the second question ask? As x approaches positive infinity. So that's saying as we go where? Right. To the right. So now they're asking, that's basically saying, what's going on the right side of the graph? What's going on the right side of the graph? The graph is also going where? Up. How do we say up? Y is approaching positive infinity. Because y is our vertical axis, right? So y is approaching positive infinity. I'm throwing in the words left, right, up, down because I don't want you to totally be lost. You're not going to see the words left, right, up, and down in the homework. you're going to see positive and negative infinities, x's and y's. I'm just trying to make it understandable. Okay, questions on that one? Okay, let's try B. Not as long as an equation. But again, did the rest of those terms matter on that equation? Nope, not a bit. Okay, g of x is negative 5x cubed plus 8x plus 4. I care about two things. Tell me about the degree. The degree is 3, and we are smart cookies, and we know that that is an odd degree. What about the leading coefficient? Leading coefficient is 5, and I don't really care that it's 5. I care that it is negative 5. Oh, it's negative 5, sorry. Okay, so right there, we care that that is negative. I'm going to back that up a little bit so I can put the whole word in there. Oops. Okay. Use your chart if you need to. Odd degree. I know my brain, an odd degree is either down and up or up and down. What if it's negative and odd? Where do we start? Where do we end? We start where? We start up and we end down. Okay? So we start up and we end down. Are you with me? Words or symbols, they're both good. But that's my visual for you. Okay. As x approaches negative infinity, what is that asking me? As x approaches negative infinity, that's asking me about which side of the graph? As we move left. Because as x is approaching negative infinity, as x gets smaller, that means we're moving left. Where's my graph going on the left? It's going where? It's going up, yes? Okay. Up is a good answer for me, but we need the fancy official answer. Up on a graph is the same thing as saying y approaches positive infinity.
So we always say the behavior in terms of y as they give us that.
Yes, yes. So in behavior, they're always going to ask it in terms of x because they're asking, okay, on the left side of the graph or the right side of the graph. And then you're going to talk about the graph is either going up or down. Okay, so yeah, they'll always ask in terms of x, you'll always answer in terms of y. So they're always asking left, right, you're answering up, down. Okay, so as x approaches positive infinity, what am I asking here? As we move to the, where?
Right.
To the right. What's the graph doing on the right side? It's going down. Well, this is a new answer. We haven't had this answer yet. How do we say the graph is going down? What's approaching negative infinity? Y is approaching negative infinity. I don't know if you've noticed, there's only two possible answers for this section. Y approaches positive infinity or Y approaches negative infinity. Up or down, those are your options.
You have 50-50.
You do have a 50-50 chance here. Okay, are we catching on? Okay, let's keep moving then. Okay, C, h of x. I'm not going to read it. You got it in front of you. What do you know about h of x?
Is 7 our leading coefficient?
Not our leading coefficient.
Or our degree?
Is 7 the important number? Yes. 7 is my degree. And what do I care about 7? It's odd. And it's my degree because it's the highest power, yes? This one just doesn't happen to be written in standard form. But it's still the highest power. And what do we notice about this term? It is what? Positive. So odd and positive. You have the chart on your front paper, yes. I'm not expecting you to have it memorized yet. What do you know if it's odd? Here's the easy thing I know. Odd is not even. So odd is opposites, right? Up and down or down and up. Which one's positive?
Downtown.
It starts down and ends up. Okay, here we go. As x approaches negative infinity, that is fancy speak for as we look at the left side of the graph. What's the left side of this graph doing? It's going where? Down. And what is that in infinities? Y is approaching negative infinity. I assume you guys can see it from where you're sitting. Realize that's an arrow I'm using, yes? Where I'm not saying y equals negative infinity. I'm saying y approaches negative infinity. So that arrow represents the word approach. Okay? As x approaches positive infinity. So that's saying as we move to the right. Where's my graph going on the right? Up. How are you giving your answer then? Y is approaching positive infinity.
I think I see it, Trey.
What, the fact that I'm using all the possibilities and there's one possibility left? I have. I'm trying to give you examples here. Okay, on D, J of x. What's my degree here? My degree is the highest power, which is 4. And what do you know about 4? 4 is even. So that means my graph is either up and up or down and down. What do you know about the leading coefficient? It is negative. What about negative? It's going to be down, down. Think about an upside down parabola. Okay. As x approaches negative infinity. So as we move to which side of the graph? As we move to the left. What's my graph doing on the left? It's going down, which is what? Y approaches negative infinity. And if you didn't already figure it out, the other one's going to have the same answer, isn't it? Because it was, in both cases, it was down and down. So this one officially, though, is as x approaches positive infinity. So as we look at the right side of the graph is also moving down. And down is expressed as y approaches negative infinity. Okay? It's doable. It's doable. You just got to get it all straightened out in your brain. Probably one of the hardest parts is knowing when to use x and when to say y, in all honesty. So, okay. One last piece I want to teach here. And in my morning class, this is where I got through the first example and not the second example. So we'll see what I can do with your class. We are being asked to sketch a graph based on the description given. Now, realize in Savas, I think that means you're picking a multiple choice graph. Like they'll give you some characteristics, you pick the graph that matches. We have to go a little farther here, and we're going to sketch this graph. Okay, so it's distinguishing what do each of these vocabulary pieces mean. So, f of x is positive on the given intervals. If a graph is positive on the given interval, where does that mean it is in relation to the x-axis? If a graph is positive, it's going to be where? It's going to be up. It's going to be above the x-axis. So realize when you see the idea that a function is positive, that is fancy speak for saying above the x-axis. Okay? And if positive means above the x-axis, what does negative mean? Below the x-axis. Okay? Now, if f is decreasing on these intervals, what's a graph mean if it's decreasing? It's going where? It's going down on that interval. If f is increasing on an interval, what's that mean? It's moving up on that interval, right? Okay. Before I do too much, I'm going to put some tick marks on my axes. If I look at all the numbers there, what, the highest and lowest are 4 and negative 4, aren't they? So I'm going to mark out 4 to the right and 4 to the left. I think I'm going to label every other just so I have some labels in there. So I labeled 2 and 4 and negative 2 and negative 4. Now, okay, think with me here. If it's positive on these intervals, positive means it's going to have to be where? Above the x-axis, yes? So now, this is me sketching in light pencil, okay? So this is not a final answer yet. This is not what I would write down yet. This is my brain working. But if something is positive on these intervals, so right here, let's work with this one first. If it's positive from negative 1 to 4, that means from here at negative 1 to here at 4, where does my graph have to be? It has to be above the x-axis, right? Not necessarily in that exact shape, but that's what my brain's thinking is. It's got to be above. Are you with me? Yep. It also has to be above the x-axis from negative infinity to negative 4, which is where? That's over here. In other words, that's saying it's coming from over there. Okay? I'm just trying to get the general shape. So what if it's negative on these intervals? If it's negative between negative 4 and negative 1, where does it have to be? Has to be below the x-axis. And where else does it have to be below the x-axis? 4 to infinity, which is what? To the right of 4. Now, to be honest, does that give you the general shape? It does. Tell me, what's happening at negative 4, negative 1, and positive 4? What's my graph doing at those points? At negative 4, negative 1, and positive 4. Switching from positive to negative, which means my graph is going to cross where? How about x-intercepts? Is my graph going to cross through the x-axis there? Yeah. These pieces, I would use the word zeros, because they're also zeros, but they're going to be x-intercepts. Okay? Now, the other part, decreasing. Follow me. It says my graph is going down. So it's going down from negative infinity to negative 2.67, which means at negative 2.67, that's where I'm going to stop going down. So realize I'm going to go down to about this point. What's going to happen at negative 2.67 then after that? I'm going to start what? Increasing. So now at negative 2.67, I'm going to start increasing. And I'm going to increase up to, dang it, 2. And then what am I going to do at 2? I'm going to start decreasing again. So these pieces right here, this was a min and a max. Okay? So, like my morning class, one example I didn't get through. I do still want you to go in and do the homework. Okay? If we need to talk about these a little bit more tomorrow, we will. Okay? Advantage in homework is you're matching it up with a multiple choice. So, it'll give you an idea of where you're at on it.